Hello, everyone. My name is Mark Cavens, and I'm a product manager here with Chef. And today we're going to be talking about scaling beyond Ansible and Puppet without starting over. The goal is to not throw away. The goal is to scale beyond the limits of those individual tools, add stronger organization and visibility without asking the team to rewrite everything from scratch. So as we go on, listen for one theme. Keep what is working, reduce the complexity around what isn't, and give operations a better way to execute and govern automation at scale. Here's the path that I'm going to take us on. First, I will frame the modernization issues we see across infrastructure teams. Then I'll talk about a recommended build approach, how to modernize around end-to-end scenarios instead of isolated tools. From there, I will show where Chef 360 helps teams scale. Then we'll get into the important part, reuse, not rewrite, and how Ansible and Chef can work together. After that, I'll move into a demo and then, of course, leave time for questions. Why traditional modernization fails? This is the reality that many teams are operating in. Let's talk about the Forrester quote over on the left-hand side. Many companies rely on incomplete tools for infrastructure. This does not mean teams have no automation. It usually means the automation is fragmented. You may have playbooks in one place, scripts in another, scheduling somewhere else, and reporting or audit evidence handled manually. The result is that teams are in survival mode. They are reacting, stitching things together, and trying to prove what happened after the fact. That is the problem we are trying to solve for, moving from incomplete, disconnected automation to a model that is coordinated, visible, and easier to govern. The other pattern that we see is the rewrite trap. When existing tools do not scale cleanly, organizations often decide we need to start a new standard. We need to start over from scratch, so let's rewrite everything. That sounds clean on paper, but in practice, it can create multiple rounds of failure. Rewrites take time. They interrupt teams that are already busy with other scheduled work, and they often create capabilities that already worked well enough already. Our point of view is different. Modernization should not begin with a blank page. It should begin with what you already have. Then add in the missing control, scheduling, orchestration, visibility, and governance around it. So let's take a look at the product comparisons. And let's look at it from a high level rather than reading every cell. Ansible is attractive because it's fast to start and it's agentless. It's great for simple tasks and for teams already having playbooks or runbooks or other workflows. But as workflows become more complex, teams often need more scheduling, coordination, and operational visibility than the basic model provides. Puppet has been powerful in large enterprises, especially where there's a specialist and a set of talent that is focused around Puppet. The challenge is that learning curve and operational model can be heavy, and many teams struggle to keep that specialist once they have them. Chef 360 is positioned for fast time to value and enterprise control. The differentiation is native job scheduling, multi-step orchestration, real-time visibility, and a path to reuse existing automation instead of forcing a migration that starts over. I want to take a look a little bit around why Chef 360 stands out. First, teams can get to first success quickly. That matters because automation programs lose momentum when the first value of proof takes too long. Second, Chef 360 gives you enterprise-grade job scheduling out of the box. You do not have to bolt on separate schedulers or workarounds. just to run operational work reliably. Third, you get real-time visibility and intuitive control. That means teams can see what changed, where it ran, and what happened. And finally, Chef 360 is built for operational leaders, not just engineers. The platforms give CIOs and operation directors the health, compliance, and performance context they need to make better decisions. Now I want to talk and shift away from the problem and move to the strategy. When we say suggestion on how to build, we are not saying start with a tool replacement project. What we are saying with the operational outcome, what we are saying is to start with the operational outcomes that matter. What scenarios need to run end to end? Which teams are involved? Which systems are touched? What evidence do you need at the end to show value? Once that is clear, then the tooling decisions become much easier. You can keep the tools that support the scenario, and you add the capabilities that close the gaps. The Forrester advice here is important. Break down team walls and build automated end-to-end functionality. In practical terms, that means do not modernize by saying this is an Ansible problem, or this is a Puppet problem, or even that this is a Chef problem. Start by defining the scenario. For example, patch this set of servers, validate this policy, report the result, and make the evidence available for operations, security, and whoever else needs to look at it. Then look at the tools you already have. If an existing playbook or script is part of the scenario, reuse it. If you need scheduling, targeting and approval, visibility, or auditability, add that layer. This is how teams modernize faster without a wholesale rewrite. This is also where Chef can come into the story. Chef has spent years helping define infrastructure as code, automate configuration, verify compliance, and run operations across complex environments. So the question is not just can Chef run automation? The question is, how does Chef help us turn automation into a repeatable operating model? That is what I want to show in the next set of capabilities that Chef has today, mostly to take a look at the fact that some may have not looked at Chef in a while. Chef infrastructure management is the configuration and desired state foundation. The way that I would explain it is this. Instead of documenting infrastructure in a runbook and hoping that everything stays consistent, you define the desired state as code. The code can be tested, versioned, approved, and delivered through pipelines. It also works across hybrid environments, on-prem, in the cloud, on the edge, with multiple operating systems. If a system drifts away from the desired state, Chef can detect that and correct it. This is how teams reduce configuration drift and make infrastructure easy to understand, onboard, and operate. Chef Compliance brings the same code-based approach to security and compliance. Instead of treating compliance as a manual audit activity at the end, you express compliance requirements as code, run them throughout the delivery process. The bullets here look at the key actions: translate compliance into code, clearly express policy, follow issues early, and inspect machines, data, and APIs. The value is the operations, security, and development can work with the same artifacts. You're not waiting until a production to discover a risk. You're not hearing, well, this worked on my machine, and you are testing it for earlier and promoting compliance content in a controlled way. Think about orchestration in 3 questions. First, what do I need to run? It could be a script, an operating system command, a cookbook, a policy, a management action of some sort, or another automated asset. Second, when should it run? On demand, on a schedule, on a reoccurring interview, or with some exceptions. Third, where should it run? A single node, a saved list, a query-based group, or a targeted subset of systems. And then choose how to distribute the work, sequentially, in parallel, or in batches. That is the control plane that turns individual automation assets into repeatable operation workflows. Chef 360 is a part of a broader platform foundation. The important word on this slide is integrated. Teams need authentication so the right people and systems can run the right work. They need monitoring so they know what happened. They need auto scaling and content management so that the platform can grow and teams can manage reusable automation assets. And they need security built around the workflow, not just added afterwards. This is the difference between running an automation task and operating an automation platform. And don't forget about choice. You can choose to run in your existing on-premise environment, or you can have Chef do what Chef has done best, which is run Chef and keep the running of upgrades, of maintenance, of the management plane, all done in addition to running the workloads on your other environments. You still get support for the multiple environments, including hybrid, cloud, on-prem, out on the edge. The value is faster time, less maintenance, and a simpler path to scaling the platform as usage grows. With over 10 years of management and over 2,000 customers across 3 iterations of Chef in the cloud, Chef knows how to host Chef best. So before we get to the next section, I do want to do a quick recap. First, change safely. When infrastructure changes are code, they can be reviewed, tested, approved, versioned, and delivered through pipelines. Second, secure and compliant infrastructure. Compliance can be built in the same delivery motion instead of handheld, manual, or a separate process altogether. Third, maintain consistency. A single code base can manage infrastructure across on-prem, in the cloud, on the edge, and automation can correct drift. And fourth, scale easily. Once the process is defined in code and orchestrated through a platform, teams can repeat it across far more systems without multiplying manual effort. I'm going to take a quick drink of water here, and then we'll move on to the next section. Keeping to the heart of the message, reuse, don't rewrite. If your teams already have Ansible playbooks that solve real problems, those playbooks represent investment. They represent knowledge and, of course, trust. We do not want to disrupt that just to say we modernized. Instead, Chef 360 can work with the existing automation and add capabilities teams need around it, whether that be job templates, targeting, scheduling, execution control, visibility, and policy level governance. This is how you get to modernization without asking teams to stop and rebuild their automation from scratch. Here's the flow. We're going to be taking a look at Ansible with Chef 360. First step, create a job template. That gives a repeatable structure instead of treating each run as a one-off. Step 2, select the Ansible playbook you already have. This is the reuse point. We are not rewriting the playbook. Step 3, execute it with Chef 360. This is where the platform adds runtime control and orchestration. Step 4, view execution and outcomes. This is critical because operational leaders and engineers need to know what ran, where it ran, when it ran, and whether it succeeded. So the story is not replace Ansible. The story is make Ansible operationally stronger inside of Chef 360. And now it's time for a demo. Before we get started, I want to go through a couple of different things. The goal of the demonstration here is relatively simple. Block incoming traffic on port 8080 on a Ubuntu VM with an Ansible playbook. This is relatively simple, and it's not incredibly complex. As a result of that, what you'll see in the demo is that it moves relatively quickly. And the way that we focus on this is in 3 main areas. The playbook is going to be executed by the Ansible interpreter on an enrolled Ansible controlled node, which is securely connected to the target system over SSH and applies the firewall configuration remotely. So no changes really on the Ansible side. The lightweight approach reduces operational overhead, removes agent maintenance, and enables nodes to be onboarded quickly without requiring modifications to their runtime environment, not rewriting. Because execution is centralized and controlled over SSH, organizations can standardize automation, maintain security boundaries, and scale workloads across diverse infrastructure with minimal friction. Now, as with all things, there are terms that are specific to what we're going to be looking at as we're setting up this demo. Now, skills, skill assembly, and cohorts have varied meanings throughout the industry, and we did want to take just a moment of time to be able to show exactly what a skill and skill assembly represents, as well as cohorts. And the skill and skill assemblies really is that reusable bundle of capabilities and actions that are going to be performed on a node, where the cohorts are the grouping together of the different nodes, VMs, whatever you want to manage inside of there. And these can all be set up so that you can do things over time with the greatest or reduced amount of impact to your infrastructure. Now, because the demo itself is only about 3 minutes, I wanted to give a quick timeline and be able to talk about this before you see what's happening in real time. And it really here, when we take a look at the timeline, one of the first things to take a look at is to verify the version of Chef 360 that you're using. If you're an existing customer, it is important to note that the Ansible interpreter was added in Chef 360 version 1.5. So if you're on an older version of that, it's always good to upgrade. If you're a brand new customer coming in, you're going to come in probably at version 1.7.3, which as of this recording was the latest version. If you're on Chef SaaS, again, you're going to be at the latest version because we always update up to latest when you're running with Chef SaaS. In the next section of the demo, you're going to see the selection of the skill assembly. So to create a new skill assembly, you're going to go to the page, you're going to create new, and you're going to name it. You're going to add the required skills and save configurations. Now, in a fully running environment, you're probably going to have multiple skills. You're going to have the default skills that are set up in Chef 360. You're going to be able to put all of those together as an entire package. We're also going to show in the demo how you create a skill. So if you haven't created any skills yet, you'll be able to see that skill creation. You'll be able to take a look at what dependencies you can add, and then, of course, saving that skill overall. Then the next thing is, of course, setting the cohorts. So creating a cohort, which is a group of servers, and then assigning it a name, and then configuring any of the skill assemblies that you want to be able to use and associate it with those skills overall. Then the next thing you're going to do is actually enroll a device. Now, of course, if you already have devices enrolled, you can simply select whatever devices you have to the new cohort and allow it to run. Or if this is your first time, you're going to enroll your first device. You're going to provide the public IP. You're then going to assign it a cohort. And after that, you're going to be able to take a look at and of course, give it its SSH credentials. And after the enrollment, you'll actually be able to see it in the Chef 360 UI and be able to associate that node ID with the information that you want. And then, of course, you're going to schedule the job that's going to block the port 8080 on the device. And that's kind of how the timeline of this environment is going to go. And that's really what we're taking a look at when we're looking at the demo. I'm going to add one more note before I actually play and kind of self-narrate the point in time that each thing is happening, but I'm going to let it happen more in real time so that you can see how fast the value you can actually get with Chef 360. So if you're going to try this yourself, just one note that I would say is first pull up a browser on the node or the VM or whatever it is that you're trying to add the information to, and then see that the VM itself is actually loading successfully using port 8080 so that you can see the before state and then know what the after state will look like. So enough from me. Let's go through and play the demo, and then we'll take a look at it from there. And again, I'm going to try and narrate a little bit as possible, but I'm going to keep it more to what you would see as you were doing things yourself. So as stated, the first thing to take a look at is Chef's documentation. We give you a full breakdown of how to use the Ansible interpreter. And as mentioned before, this is for versions 1.5 and above. And then at that point in time, you are able to use the interpreter itself. Going into node management, the first thing that's going to happen is we're going to create a new skill assembly. And naming it so it's easy to use is always the best practice. You're going to then add in the different skills that you have. And as you can see here, we have quite a few skills that are already set up. And so with there, again, I do want to state that we will do a quick look at what it takes to create a skill. And again, you have multiple skills that you can add to each skill assembly that you're working with. All right, so defining a skill. If for some reason you don't have the particular thing that you need, that's where you would define a new skill. Again, naming it so that it makes the most sense. And then you're going to add in any of your existing lockdowns that you already have. And then that's going to create the ability for you to create the cohort. Again, of course, naming it in a way that makes sense for what you're going to use for this particular job. Giving it a description if you need, and then of course giving it the skill assembly that you just finished setting up. Next, you're going to go through and actually enroll a node. So this is where you're going to have that IP. You're going to be able to set up the cohort, and you're going to be able to put the information. Once the device is registered, of course, you can see how fast it ran through. And then we're going to create a job. And that job is going to be to block the firewall on port 8080, or I'm sorry, it's going to be to block the browser on port 8080 using the existing cohort that we just set up. And as you can see, the before state, port 8080 is open. And then at a point in time, the job will execute and we'll block it there. So in just a moment, we'll see the result of the job running. And as with everything, it may take a moment for that to happen. And what you're seeing there is a copy of what the actual Ansible job was. And we see that the job is scheduled successfully. We'll give it a moment for it to actually run, and you can see the success of the blocking of the rule itself. And then we'll go back to the actual browser so that you can see on a refresh of the browser that the port is now blocked and you can't hit on port 8080. And then, of course, having that before state and that after state, giving us the end-to-end result that we're looking for. That's a brief demo of what the orchestration looks like using Chef to orchestrate and Ansible in order to create the playbook that you would already be using today. So conclusion. Let me close by bringing the story back to the opening promise. Chef delivers automation, compliance, and job scheduling in a single platform. That matters because most teams are not struggling with a lack of individual tools. They are struggling with too many disconnected tools, too much manual coordination, and not enough visibility into outcome. Chef 360 helps unify teams and tools, making it easier to see, and follows a modernization strategy, build end-to-end scenarios, reuse what already works, and add platform capabilities needed to scale. The next step is simple. Do not just let us show you how you can work in your environment with Chef. And for those folks that haven't seen Chef 360 beyond the 3 minutes that we just showed as a part of the demo, we do have a quick run through that is running on chef.io today. If you'd like to explore that more, please feel free to take a look at the demo that we have on Chef. And if you want to learn more, please visit chef.io and take some time to take a look at everything that Chef can do for you today. Now, that's the end of the presentation side. Do we have any questions that we might take a look at? I'm going to switch over to the other phase of that, so I can see if there are any questions that are going on, and then from there we'll take a look at what else we can do. Okay, so we showed one thing we showed Ansible. The question is, are there other tools that you can work with today? Yes, we do have some things that you can work with Puppet. We also have ways of taking existing playbooks that are within Puppet and converting them inside of Chef today. Kimball, do you have any?
Yeah, so I should quickly introduce myself. I'm a technical product marketing manager, and I've been working with Chef for, well, I started working with Chef in around about 2011, so it's been a long time now. Yes, we natively, right out of the box, we're supporting Ansible, Chef Infra Client, Chef Inspec, the ability to restart a machine, which is often very important to have a controlled manner of restarting, and then shell commands. But you can build skills are built with Habitat. So you can very easily build new interpreters, and you can also run things through the shell integration. And this is all very simple to do. So yes, right now Ansible is a first-class citizen, but other tools are going to come, and you can write your own very, very easily. So it's an incredibly flexible system. And as some of you may have seen, the blog post that I've been working on, which is about automation without rewrites, the idea of the control and the governance is what's important about 360. The tools that you can run whatever makes sense for you, and I'll be going into more detail across the course of the blog series on how you can do other things, including even managing things like Kubernetes and network devices.
Awesome, thank you for that. Another question that I had here is, what's the realistic timeline and level of effort to reach first value on an environment? Now, again, I showed a relatively quick example. Whether or not that would show value to upper stakeholders or not is debatable. But again, taking a look at what you have built today and then seeing how much you have to do inside of Chef 360 to get things started, you're talking generally within the first day, you can start to see your existing workloads go through and then scheduling into there. Kimball, do you have anything you'd like to add on around, time to reach first value?
I mean, absolutely. Like, as I think is a great example, when we do this in workshops and demonstrations, you can get up and running with this in less than an hour, especially using Chef SaaS. And beyond that, like everything is designed to be very simple. And so your imagination is what lets you carry on. You understand the basics very, very quickly, and you can get going very, very quickly. And then you can just start to apply that to the jobs you've already got. Other things are a little bit more complicated. We showed here just like a single step job, but you can do multiple step jobs that use multiple interpreters and have different things that are set up based on, what happens if something fails. If you can set things up into canary deployments and then go expand further on that. But every individual piece is very simple, and it's just a matter of setting up the right steps. So it never becomes overly complicated, but it's got, as with everything with Chef, huge amounts of power.
Awesome. Thank you for that. Last question that I have before we can open it up for any others, that I see here is, can Chef 360 run in air-gapped or on-prem only environments as well as SaaS? And what are the changes in that model? So the answer to all of those is yes. With the flexibility of Chef, you can run on-prem. You can run on-prem in an air-gapped environment to where nothing really talks to the internet. In SaaS, air-gapped is not a capability today, but you do have the ability to keep your more secure devices running in whatever motion you want. Kimball, anything you want to add onto that explanation?
I think an important thing there as well is that even if you're not running a fully air-gapped system, so you have some connectivity, the 360 does not make connections to your hosts. Your hosts have an agent that is talking to Courier. So you can have a very restricted firewall rule, still be managed by Chef SaaS, and not have any risk of anything coming into your machine that you're not expecting. You're not having to have SSH running. It's all run with a zero trust model.
Awesome. Great. I'll check the chat here real quick to see if there's any other questions. If not, then we can convene a little bit earlier than the full hour. And at this point in time, I don't have any other questions. I'll stay on for a couple more minutes to see if there's anything else that we need to add. But if not, I hope everyone has a great rest of your day and hope to see you on the next session.